Hey guys, we're on to the next lesson. This will be a shorter lesson. It's simplifying and evaluating exponential expressions, piggybacking off of our last lesson. All right, so now I'm going to kind of tell you the difference between simplify and evaluate an expression. All right, so simplify. Simplifying is kind of what we did in the last section. This is where we apply the rules of exponents that we're going to learn and that we have learned, like with a negative exponent. We don't actually compute the number. That's when we evaluate. All right, when we evaluate, we find the value. We apply the exponent to the base and we calculate the answer. We actually multiply it out. All right, simplifying it, we leave it in exponential form, meaning there's a base and an exponent. When we evaluate, there is an actual answer, a number without an exponent. All right. So how can we simplify something that's a little bit longer now? Okay, how can we simplify this? Well, what we want to do is think about the problem being 5 times a cubed times b to the negative second. All right. And to simplify it, we got to think about, oh, is there anything I can simplify? Well, 5, there's nothing I can really do to 5. If I want to think about it, there is an invisible one exponent. I don't need to simplify that, okay? There's nothing I can do. A cubed, a times a, nothing I can do there. That's simple. B to the negative second. Aha, this is what we need to simplify. All right, as we said last lesson, if it has a negative exponent, it's not simplified. So what I need to do is I only need to take this piece. All right, I'm still going to have a 5, and I'm going to have an a cubed. All right, but what I need to do with this is I need to make that 1 over b squared. I need to do the reciprocal of that. The base stays the same. It still stays a b, but now the exponent's positive. All right, so then I could say times 1 over b squared. But now there's an easier way to write all of this, okay? I could just write 5a cubed over b squared. All right, because if I multiply this across, technically that's over 1. When we multiply fractions, it goes straight across. And there we have it. All right. Next, let's simplify each one of these that start with a. What do you think? Is that 7 okay? Yeah, that 7 is just fine. All right. It's this w. That's the problem. It has a negative exponent. So I need to make it have a positive exponent. The way to make it have a positive exponent, well, is move it to the denominator now. And the exponent becomes positive. Okay, a common mistake. Students remember to move it to the denominator, but then they keep the exponent the same. You have to make the exponent the opposite. All right, let's take a look at b. What do you think about b? The negative 5 is fine. Even though it's negative, it doesn't have a negative exponent. All right, this is the problem. The k to the negative second on the bottom. I need to move it up to the top. So now it's just going to go alongside the 5, and the exponent is positive, negative 5k squared. All right, see, this one's a little bit fun. I enjoy these, and I know I'm a nerd, whatever. The longer problems, I like to just put a fraction bar right away. All right, and I'm going to treat each base individually. Okay, I'm going to look at a, it goes in order. A to the 0 power. Well, what's anything to the 0 power? That's right, it's 1, so that's gone. It's just a 1. All right. I'm going to move on to this b. This b squared, this b to the negative second. It's no good. It's in the numerator now. So in order to simplify, I'm going to move it to the denominator, and this exponent of negative 2 now becomes positive 2. Check. My c. My c has a negative exponent. No good. I need to make it positive. But since it's negative in the denominator, it would become positive in the numerator. So the c moves up top, staying c, and the exponent just becomes the opposite. Now I'm going to do d to the 6th. My exponent is fine. It's positive. So that's going to stay in the bottom, okay? And this is our final answer. Some students say, well, what about that 1? Oh, I could say times 1, but that's excess. We don't need to do that. Okay. Sometimes we do need it as a placeholder, but since there's something in the numerator, that's it. Okay. So this is our last little piece. This is when we're going to actually now evaluate. See how it says what's the value of 3s cubed t to the negative second for s equals 2 and t equals 3? That means we're going to plug these in, and then I need to figure out what the actual number is. So the first thing I want to do is just rewrite it. Instead of s, I'm going to write 2 cubed, and instead of t, I'm going to put the negative in parentheses to the negative second. Okay. Now, the first thing I'm going to probably want to do is to simplify it. All right. Kind of what I did on the previous page. This negative 3 to the negative second, that's no good. All right. Because of the negative exponent. So what I'm going to do is I'm just going to move it to the denominator here. I'm going to put it negative 3 to the positive second now. And now I'm done with that. All right. So now my problem becomes 3 times 2 cubed all over negative 3 squared. All right. So I'm just going to kind of draw an arrow, go around that little mix up. This becomes 3 times, well, 2 times 2 times 2 is 8. We did that last lesson. And negative 3 squared means this becomes negative 3 times negative 3 over 9. This just becomes 24 ninths. We evaluated that. We got an answer. Notice there's no exponents in my answer. That's it. You're going to complete the 7-1B practice and the mastery check.